Yeah. Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening,
Good
ma'am.
evening, ma'am.
Yeah, I've shared my screen, children. Is it visible?
Yes, ma'am.
Yeah. Okay, so today we are taking the introduction to the formulae of this chapter, volumes and surface areas. So before I share something, let me ask you, tell me the formula to find the length of the diagonal of a cube. The formula or the expression to find the length of the diagonal of a cube. Okay, the length of the diagonal of a square. Square is a plane figure. Square is a plane figure. So length of the diagonal of the square is given by? Okay, root 2a units. Root 2a units. Length of the diagonal of a square is given by root 2a units. You can just imagine the right triangle AA. So Pythagoras theorem, a square plus a square, no? Right triangle, square, join one of the diagonals. Join one of the diagonals. So the diagonal square is equal to a square plus a square. Why am I doing in the air? Let me do it here. See, square, the rectangle. Okay, so square, diagonal, AA, right sides, AA, all the sides equal. So this one is a right triangle because every corner in a square is a right angle. So this is a right triangle. Let me call this D. So by Pythagoras theorem, D square is equal to A square plus A square. Pythagoras theorem, in a right triangle, the square on the hypotenuse is equal to the sum of the squares of the other two sides. So D square is equal to A square plus A square. So D square is equal to 2A square. So D is equal to square root of 2A square. So root 2 remains under the square root. A square comes out of the square root as A. A square out of the square root as A. 2 remains on because it doesn't have a pair, right? So 2 remains under the square root. So root 2A is the formula to find the length of the diagonal of a square. Cube root 3A. Again by using Pythagoras theorem only. So root 3A is the formula to find the length of the diagonal of a cube. Now, what is the diagonal of a cube? Which is that line segment? It is a line segment. Now, if you imagine this room, or online students, just imagine the room in which you are sitting to be a cubical room. Okay, just imagine you're sitting in a cubical room. So the line segment connecting, choose any one bottom corner. Choose any one. So I'm just choosing that bottom corner. The line segment connecting that bottom corner to its opposite top corner. That is the diagonal of this cubical room, and that represents the length of the longest rod that can be placed in this cubical room. The line segment from choose any corner. So if I choose that corner, the line segment connecting that bottom corner, bottom floor corner to the opposite top corner, diagonally opposite, not straight opposite, to its diagonally opposite top corner. Bottom corner to the diagonally opposite top corner. That line segment is the diagonal of a cube. And if it's a cuboidal room, the same is the line segment that represents the diagonal of the cuboidal room. All right. So now the length of this diagonal of the cubical room given by root 3A units. All right. Okay. How many edges does a cube have? How many edges does a cube have? 8 edges. 12 edges. Yeah, online students, how many edges does a cube have?
12, ma'am.
12 edges. 12 edges. Yeah. Just imagine this one to be a cube. I don't have a cubical object with me now. So this one is cuboidal. So the edges are the same. So we have 4 vertical edges. 1, 2, 3, 4. 4 vertical edges. This one. 4 vertical, 1, 2, 3, 4. 4 vertical edges. You can use your book to understand. You can just lift your notebook and understand. So 4 vertical edges. Then you can see the edges on the top. No, 1, 2, correct? So there are 2 edges on the top lengthwise and 2 edges at the bottom also lengthwise. So there are 4 edges lengthwise. 4 edges lengthwise. 1, 2, 3, 4. 4 edges lengthwise and 4 edges breadthwise. 1, 2, 3, 4. So both a cube and a cuboid have 12 edges, 4 edges along the length. Lengthwise, top 2 edges, bottom 2 edges along the length. Breadthwise, 4 edges. 1, 2, 3, 4. 4 edges along the breadth and 4 vertical edges. The remaining 8 edges are horizontal. 8 edges are horizontal. 8, you can see this room, like 1, 2, 3, 4 edges on the top, bottom 1, 2, 3, 4 edges, and 1, 2, 3, 4 edges. So 4 edges vertically, 4 vertical edges, 8 horizontal edges. Okay, so 12 edges in all. In a cube, all the 12 edges are equal. In a cube, all the 12 edges are equal because a cube, all sides are equal, right? So the length of all the edges of a cube, length of all the edges of a cube is given by a plus a plus a plus a 12 times. So 12a, because 12 edges, right? Each edge has a length of a units. So a plus a plus a 12 times, so 12a units. In a rectangle, 4l plus 4b plus 4h, because we have 4 edges along the length. So L plus L plus L plus L. Then B plus B plus B plus B. Then H plus H plus H plus H. So we have 4L plus 4B plus 4H. So if the question is what is the, you have a gift inside, you have put a gift inside a cubicle or a cuboidal box, and you want to fasten all the edges with sellotape. You want to fasten all the edges. You want to bind the edges using a sellotape. What is the length of the sellotape needed? Can be the question. What is the length of the sellotape? Length of the sellotape needed to fasten all the edges of a cuboidal box or cubicle box. If it's a cubicle box, the answer is 12a. 12 into side. If it's a cuboidal box, it is 4L plus 4B plus 4H. You will be given the length, breadth, and the height of the box. And similarly, the length of the diagonal of a rectangle is given by, you will tell me now. Now you know it. How do you find the length of the diagonal of a rectangle? What's Pythagoras' theorem here? Diagonal square is equal to
L square plus B square.
L square plus B square. So diagonal is equal to square root of L square plus B square, which is not equal to L plus B. It's not equal to L plus B. It is square root of L square plus B square, because you need to add and then take the square root. You cannot take individual square roots like this. It's not square root of L square plus square root of B square. If it was square root of L square B square, yeah, then it is LB. L square root of L square plus B square. It is not L plus B. Okay, so D is equal to square root of L square plus B square. So the length of the diagonal of a rectangle is given by square root of L square plus B square. Now for a cuboid, the length of the diagonal of a cuboid is given by square root of L square plus B square plus H square. Just connecting so that you can remember. Square diagonal root 2a, cube diagonal root 3a, rectangle diagonal root of L square plus B square, cuboid diagonal root of L square plus B square plus H square. The rest of the formulae related to a cube and a cuboid, I think we'll see when we take up the questions. You should know them. Cylinder also. Now, okay, we'll do. Yeah, now cylinder. Cylinder. Tell me, what is the formula to find the curved surface area? Anybody online, offline? Okay, online students also. The formula to find the curved surface area of a cylinder. 2 pi RH. 2 pi RH. CSA of a cylinder is given by 2 pi RH. Curved surface area is always perimeter into height. Volume is area into height. You should remember that. CSA is always perimeter of the cross section into height. Volume is area of the cross section into height. Volume is area into height, basically. Volume is area into height. So what's the area of a circle? What's the formula to find the area of a circle?
Pi r square.
Pi r square. Now that's the area. Okay, so what is the cross section of a cylinder? Circle. The cross section of a cylinder is a circle. Area of the circle is pi r square. Height of the cylinder h. Area into height. Pi r square into h. Pi r square h is the formula to find the volume of a cylinder. I think we'll come from the beginning then. Maybe 9th standard you've forgotten. So it's totally. Yeah. No, go through this slide because when it's too easy, I find it difficult to explain. You can understand this yourself. Please help yourself. Go through the formula. Any questions you can ask me, children? Read the slide completely. Root 3 is again by using Pythagoras theorem. See here, this considering this right triangle. This is the right triangle. Considering this right triangle and again Pythagoras theorem. This one is root 2a because the base is square. So this one is root 2a. This one is a. So again using Pythagoras theorem, this is root 3a. So if you have a cubical box which is open at the top, if you have a cubical box open at the top, what is the formula to find the area of cardboard used to make that box? 5a square. 5a square. Because it's a cubical box open at the top. So there is no material used on the top. For what will you find area? If the material is used there, you should find area. If there is no material, what area are we finding? Okay, so you find area only if there is material used for that surface. So if it is a cubical box which is open at the top, that means it has only 5 faces. Now supposing this room, there is no ceiling. So there is only 5, meaning 4 walls in this floor, no ceiling. So the area of this room, the total area of the room will be the area of the 4 walls plus the area of the floor. Why will I find the area of the ceiling when there is no ceiling at all? So for a cubical box or a cuboidal box which is open at the top, you have to find the area of only 5 faces. So if it is a cube, it is 5a square because each face is a square. Each face is an area of a square. So 5 faces, 5a square. If it's a cuboid, what is the area of the 4 walls of a cuboid? Okay, so I think no problem. I think we have forgotten, no? Or maybe suddenly when I'm asking, like it's difficult to recall. Okay, now is this fine, children? Let me not ask you questions. We'll do it together. Now is this fine, children? A cube. All this is you can recall easily, right? Area of 4. This one. So you can see CSA is perimeter of the cross section into height. Area volume is area of the cross section into height. Curved surface area is perimeter of the cross section into height. So what is the perimeter of the cross section? What is the cross section square? What's the perimeter of a square? 4a. 4a into height a. So 4a square. Or you can also understand CSA as area of the 4 vertical faces, right? Curved surface area is area of the 4 vertical faces. 1, 2, 3, 4. So 4 vertical faces, a square, a square, a square, a square. So you can understand like this also. The curved surface area you can understand as the perimeter of the uniform cross section into height. Cross section is a square. Its perimeter is 4a into height a, 4a square. Like this you can understand. Or by adding the individual areas, a square, a square, a square, a square, 4 walls. So 4a square. Area of 5 faces will be CSA plus area of the base. So 4a square plus a square, 5a square. If you want to find area of all the 6 faces, then it is CSA, area of the base, area of the top. So 6a square. Length of the diagonal, root 3a. Length of all the edges, 12a. Okay, so this is about a cube. I've shared the image. Cuboid. Cross section, rectangle. Cross section, rectangle. Area of the cross section into height is volume. Volume is area of the uniform cross section into height. So cross section is a rectangle. Area is L into B into H. So LBH cubic units is the formula to find the volume of a cuboid. Volume is what? Area into height. Area of the cross section. The cross section is a rectangle. So area of a rectangle L into B. Area into height L into B into H. LBH. Now CSA is curved surface area is always the area of the 4 walls. CSA for a cylinder, CSA for a cube or cuboid is the area of the 4 walls. Curved surface area or lateral surface area. Lateral surface area. Both are the same. So area of the 4 walls. So CSA or LSA is understood as perimeter of the uniform cross section into height. Perimeter into height. So what's the perimeter of a rectangle? Cross section is a rectangle. What's the perimeter? 2 into L plus B. Rectangle. Perimeter 2 into L plus B into H. So 2 into L plus B into H is the formula to find the CSA or the lateral surface area of a cuboid. Or you can also understand like this. Area of the 4 vertical faces, the front area of the front face, back face, left face, and the right face. So like that separately also you can. Anyways, now see, these are important to understand, but now we understood the formula. So I'm moving ahead. I'm not trying to explain all this. This is 9th standard presentation actually. So I'm not doing all this and spending your time. So you understand this formula, 2 of L plus B into H. Now, area of the 5 faces. So when we see when it's a cuboid, CSA is always there. CSA is always there. 4 walls. Then if the floor 5 walls, meaning 5 faces, with the ceiling 6 faces. Now, if you want to find the area of 5 faces, it's a CSA. So it will be the CSA plus the area of the base. So that means CSA is 2L plus B into H plus LB. Work it separately. You don't have to. Area of 5 faces. So you find area of 4 faces, 2 of L plus B into H. You find this answer. Then find the area of one more face, L into B. L into B. Because floor area is L into B. Ceiling area is also L into B. Yeah, so find this separately and add. Find the area of the 4 walls. Find the area of the floor and add to find the area of the 5 faces. Area of all the 6 faces, children, you know, 2 of LB plus BH plus LH. Okay, so we are not going to all this. 2 of LB plus BH plus LH. All right. Length of the diagonal, root of L square plus B square plus H square. Length of all the edges, 4L plus 4B plus 4H. Is that fine? Cylinder, cross section, circle. Cylinder, cross section, circle. Volume is area of the cross section into height. For a cylinder, the cross section is a circle. Area of the cross section is a circle. Area of the circle is pi r square. Area into height, pi r square into h. Pi r square h is a formula to find the volume of a cylinder. Curved surface area is perimeter into height. What's the perimeter of a circle? 2 pi r. Circumference, 2 pi r. So 2 pi r into h, 2 pi r h is a formula to find the CSA, the curved surface area of a cylinder. Now, a cylinder has meaning one curved surface and two flat surfaces. A cylinder has one curved surface and two flat surfaces, two circles, and one curved surface area. So it has one curved surface and two plane surfaces, right? Or flat surfaces. So the TSA of a cylinder will be CSA plus area of base plus area of top, 2 pi RH plus pi r square plus pi r square. So on taking common, pi r square plus pi r square is 2 pi r square. And on taking 2 pi r common, in bracket you'll get r plus h. H plus r you'll get r plus h. It's all the same. Taking 2 pi r common, children, 2 pi r is common. So 2 pi and 1 r is common. So the other r, h plus r in the bracket or r plus h. So this is the formula to find the total surface area of a cylinder. 2 pi r h is CSA. 2 pi r into r plus h is TSA. Now supposing you have a cylinder which is open at the top, like a tumbler, a cylindrical tumbler. So a cylindrical steel tumbler, where is the material steel used? Only to make the curved surface area and the bottom of the tumbler. The top of it's a tumbler, so it's open at the top. So there is no steel used on the top. So how will you find the area of the steel in this tumbler? The question will be find the total surface area of steel used in the tumbler. You don't go by the word total. Total surface area does not mean this formula always. Total surface area does not always mean that you should use this formula. You should consider that object, that solid. In that solid, wherever the material is used, all that area you should find. That is what is meant by total surface area. Supposing they give you the object, a tumbler. So you know where steel is used in the tumbler. It is used only to make the curved surface area and the bottom of the tumbler. So there is no steel used on the top. The question will be find the total area of steel used in making the tumbler. Total area of steel used in making the tumbler. So you should not use TSA formula. This formula has the CSA, area of the base and area of the top. So you will be finding one extra circle area here. So you should use this formula. You should find 2 pi RH separately. That is find the CSA. Then find the area of the base, circular base, pi r square, and add both. Where is steel used in the tumbler? CSA. So that means 2 pi RH. Where else is steel used? Bottom, base. That's a circle. So pi r square. Top is open. So that's all. Find this one and this one separately and add both. That's the total area of steel used to make the tumbler. Total area, but it's not this formula, total surface area formula. Then the next is, what is called a cylindrical shell or a hollow cylinder. A hollow cylinder or a cylindrical shell. So now this is a case where a cylinder, this is a case where the wall of the cylinder is thick. The wall of the cylinder is thick. Okay. See, like when you make a cylinder using a paper, the wall is thin. You bring the your notebook paper, it's rectangle. Just bring the opposite edges together. Just fold it like this, bring the opposite edges together. It makes a cylinder, but it's a hollow cylinder because it's open at both the ends. It's open at both the ends. When you make a cylinder using a paper, so here you can see below. When you make a cylinder using a rectangular piece of paper or a square piece of paper, need not be rectangular. Okay, a rectangular or square sheet of paper, you can bring the opposite edges together and make a cylinder, but that cylinder will be open at the top and bottom. You can see from one end, you can see through the other end. Okay. So now what do you say about the wall of the, what do you say about the wall of the cylinder, which is made from paper? It's very thin. Now, supposing you find the internal radius from the center to the inner wall, you get 5 centimeters. From the same center to the outer wall, do you think the external radius will be larger or, like more like, no, it'll be maybe little more, but so negligible that it's almost equal to the internal radius. Even if you try to find the external radius is outside. See here, this one. It doesn't make any difference, so it's difficult to show. Now you will be like you're saying the same thing. You're showing the same thing. So like from the center to the inner wall, this is. Center to the outer wall is like just outside the paper. It's immediately outside the paper. Do you think there'll be a difference? No, the internal radius and the external radius will almost be the same. Okay, so that means this is also a hollow cylinder, meaning which is a hollow cylinder? This is a hollow cylinder. If you make a cylinder using a piece of paper, it's a hollow cylinder. Now this hollow cylinder, the wall is very, very thin. Okay, so the thickness of the wall is negligible. You can ignore the thickness. This is a hollow cylinder here, made from paper. Now, if you have a thick sheet of iron, you have a thick sheet of iron, and you have a thick sheet of iron, and you bring, the opposite edges together. That also will make a cylinder. It'll be a hollow cylinder. Again, you can from one end you can see through the other end, but the wall is thick. The wall is thick. That's what you see in this figure. That's what you see. It's a hollow cylinder, meaning from this end you can see through. You can see through, but the thing is the wall is thick. The wall is thick. So this is called a cylindrical shell or a hollow cylinder. Again, hollow cylinder, that is also a hollow cylinder. But you can make out, if the wall is thick, you will have 2 radius, one inner radius and one outer radius. If the wall is thin, there'll be only 1 R. Or in other words, this R and this R, the value is almost the same. But when the wall is thick, the inner radius maybe is 4 centimeters. The outer radius is 5 centimeters. So the thickness of the wall is 1 centimeter. The thickness of the wall is 1 centimeter. Now, have you seen this between a nut and a bolt? There'll be a washer kind of. Have you seen that? It's a plate. It's a metal plate. Or maybe for ear studs, we have that white color thing, which ear studs. So if the stem of the ear stud is very long, then we use a plastic thing and then to tie so that it sticks to your lobe, the earring. That is an example of this ring. Ring meaning not the ring we wear. It's a ring where the ring. So it's this like this. This one is empty. This one is open. Like this is empty. There's no material here. That's what you see here. There's material only here. There's material only here. Supposing this one is made of metal, there's metal only here. This one is empty. There's no metal. You can like put it inside your finger. This one is hollow. Now, when you stack many rings like this, if you have many identical rings like this is called a ring. It's a metal. It can be a metal plate, whatever material it is. Now, if you have many identical rings like this, you stack them. That will form a hollow cylinder with a thick wall. You can imagine that. You can imagine that. If you have a ring like this, what is this ring I'm saying? It'll be circular. It's like a disc like this, but there'll be no material here. Like you can see through. If you put it in front of your eyes, you can see through it. So there is no material here. You can see through this one. You can see through this. The material is here. Here, the material will be there. Plastic, metal, whatever it is. So if you have many, this one is I. I just do that to show that you can see through. There's no material there. Okay. So if you have identical rings like this, you have identical rings like this and you stack them to any height, that forms a hollow cylinder with a thick wall. Finished? That forms a, so the cross section, I'll tell you what next. So the cross section of a hollow cylinder or a cylindrical shell with a thick wall is a ring. It'll be a ring like this. I don't have a band of sellotape, you know. Sellotape, that broad, for these courier packages we have that brown colored big sellotape bands, no? That is a perfect example of a hollow cylinder. So the wall is thick. You will have seen the sellotape, no? Even if you don't have one at home, you've seen it in a stationery shop. The brown, broad, tapes. So when you buy it from the shop, it's thick. That's a cylinder. And the wall is very thick. The wall is thick, okay, not very thick, it's thick. So there is something like the inner radius and outer radius. Because the wall is thick, you can measure the internal radius and the external radius. But there's only one height. That cylinder has only one height. There's nothing like internal height and external height. Height is only one height. But radius will be internal, like two different radius you'll have. So that sellotape band, is a perfect example of a hollow cylinder where the wall is thick. So that object can be formed by arranging, by stacking many rings. If you have many rings like this, you stack many rings to any height, you'll get a hollow cylinder with a thick wall. So the cross section is a ring. The cross section is a ring. So how do you find volume? Area of the uniform cross section into height. Again, going down to 8th standard, we have understood how to find the area of this ring. It is the area of the outer circle minus the area of the inner circle. Area of the ring, area of this region. This one is the ring. Area of the ring is equal to area of the outer circle minus area of the inner circle. So pi capital R square minus small r square. This is the formula to find the area of the ring. So the area of the uniform cross, okay, hollow cylinder, cross section is a ring, volume is area into height, area of the cross section into height. Area of the cross section is pi r square minus r square into h. So that is the formula. Pi h into capital R square minus small r square is a formula to find the volume of the material, because volume here is the volume of the material used in the cylindrical shell. I told you it can be called the cylindrical shell or a hollow cylinder. So if you want to find the volume of the material in that object, then it is pi h into capital R square minus small r square. Or you can also say pi r square minus r square into h. This is the area of the uniform cross section into height. So it can also be understood like this external volume minus internal volume. I'll just say once about this one. See if you can understand. It's like as if it was a solid cylinder. That sellotape band, no, it was like as if it was a solid cylinder, and from the middle, one cylinder is removed. The resultant is that sellotape, what you get in the shop. Just imagine like that, as if that sellotape was originally a solid cylinder. So from that solid cylinder, whose volume was pi r square h, you remove a cylinder from the middle with the same center. You remove a cylinder from the middle. So you're removing, meaning you should subtract. And the volume of the cylinder you remove is pi r square h. Height will be the same. That radius will differ. That's why r square. So this is the volume of the original solid cylinder. From that, you're removing another cylinder of radius r. This is the volume of the resultant material. So you can take out pi h common and you'll get r square minus r square. So you can understand this formula as external volume minus internal volume. That way also you can get the formula, or area of the uniform cross section into height, pi r square minus r square into h. So like that. You can also write it as pi r square minus r square into h. Anyway, it's multiplication everywhere, so you can write it like that. Area of the ring is this one, pi r square minus r square, the area of a ring. Two rings will be into 2. 2 into pi r square minus r square. Correct? So this year, frustum of a cone, the only extra thing for 10th standard was frustum of a cone, and that's deleted from last year. It's removed from the syllabus. Frustum of a cone. No, I think ever since COVID, it's been taught in school. So that means all of 8th and 9th standard only, nothing extra for 10th. Formula wise, nothing extra for 10th standard. All these formulae we see in 9th standard. Formula wise, only that was extra, that frustum of a cone. Since that's removed, all these formulae are of 9th standard. Nothing new for 10th standard. You have a few situations different for 10th standard. That's all. And so this is about hollow cylinder. Yeah. So now talking about the surface area. Now we were talking about the volume. We were talking about the volume, right? Now talking about the surface area. I badly want to sellotape, so now that's the difficult. Okay, let's just we'll just imagine that this wall is thick, okay? It'll be 2 minutes. So we'll just imagine that this wall is thick, okay? This wall is thick. It's thick. This wall is thick. This is a cylinder. Now the surface area of the hollow cylinder will be inner CSA plus outer CSA plus the area for ring. There'll be a ring, no? There'll be that band on the top, that width on the top here. So area of the ring on the top plus the area of the ring below. If you have to paint a cylinder or a cylindrical shell, if you have to paint a hollow cylinder or a cylindrical shell, meaning the wall of the cylinder is thick, if you have to paint, then what are the surfaces available to be painted? You can paint the inner CSA, inner curved surface area, the outer curved surface area. Then there's a ring on the top, pi r square minus r square on the top, and there's one pi r square minus r square below. So these are the 4 different surfaces which you can paint. Inner CSA, outer CSA, area of the ring on the top, area of the ring below at the bottom. So CSA formula is 2 pi r h. This is cylindrical. No, when you paint this, what is the shape? Cylindrical. When you're painting inside here, the CSA, what is the shape like? It is cylindrical. And what is the formula to find the CSA of a cylinder? 2 pi r h. So for inner CSA, use small r. For outer CSA, use capital R. CSA of cylinder is 2 pi r h. Now here there are 2 curved surface areas. One is inside, one is outside. So for the inside one, use small r. For the outside one, use capital R. 2 pi small r h will be the inner CSA. 2 pi capital R h will be the outer CSA. Area of the ring on the top, pi bracket r square minus r square, same thing below. So you can see it in the slide now. So you don't have to read description. You can, if you want, you can understand, but you need to remember this formula. That's very important. This one is important for you. So the explanation is inner CSA. So curved surface area is always perimeter into height. So perimeter of the inner circle, 2 pi r into h, 2 pi r h. Outer CSA is always perimeter into height. Outer perimeter, circle, outer circle perimeter, 2 pi capital R h, 2 pi r h. So this is inner CSA. This is inner CSA formula. This is outer CSA formula. So supposing you have to find the curved surface area, you can find this separately, and add. That's what it is here. If you want to find the total surface area, it is a CSA, that is the inner CSA, outer CSA, plus the area of the 2 rings. Again, you don't remember this formula, children. Okay, 1 minute. Just a minute. Some of you are writing 1 second. See, when you're finding the total surface area, you find separately. You find the inner CSA separately. Find the outer CSA separately. Find the area of one ring. Multiply that by 2. You'll get the area of 2 rings. Add all these answers. You don't have to remember this formula. Don't. No, if you want to, you can, but not needed. You can. And here also, when you're working, see, I'm saying how to find the TSA of a hollow cylinder. Find inner CSA, 2 pi RH. Find outer CSA, 2 pi RH. Find the area of 2 rings, 2 pi R square minus R square. Now find all this in pi. Don't use the value of pi. When you're finding this, don't say 2 into 22 by 7. Don't use 22 by 7. Use pi itself. Use pi itself. So like that, you can save time in calculating. 2 into pi. Substitute R and H. Put the value for R and H. So you'll get like some 50 pi here. Okay. So maybe, okay, let me do. So maybe for this you get, I'm just seeing it. So for this, 2 pi, you substitute R and H, you get say like 40 pi. Okay, 40 pi. And for this one, you substitute, you get say 30 pi. 30 pi. And for this one, you get say 7 pi. Okay. Don't use the value of pi. Why don't use the value of pi? Because you can save time in calculation. It's easier to find when you don't put the value of pi, no? It's easy to find the answer. So 40 pi, 30 pi, 7 pi. Now add everything. So that will be 77 pi. Now use the value of pi, 22 by 7. 7 ones are 7 11, like this. Once for all, use the value of pi. So find this one in pi, this one in pi, this one in pi. Add everything. The answer is also in pi. Then once for all, use the value of pi, 22 by 7. You can find the total surface area. So this is inner CSA, this is outer CSA. This is enough actually. Just remember inner CSA, outer CSA, and area of ring formula. That's it, you can help yourself. So you can see the image below. Hollow pipe. Normally, the question, if it is a pipe, that means it is a hollow cylinder. If the question says it's a pipe, it's a hollow cylinder like this. You can see the figure below. All of you have carried your phone today? Yeah, so you have received the images. So I want you to make a list of the formula alone, meaning don't write the description. Just write cone. Not now, I'll just finish. Just write cone, meaning start with cube. Just write cube, volume, CSA, TSA, like that. Just the final answer for you to memorize them. Don't write description. Don't write area of the uniform cross section. Don't write anything. Just the final, expression, and prepare that list. Okay. Now I've shared the images on WhatsApp. Okay. Oh, but you're not in the group. I'll send it to you. Yeah. So this one I'm not saying because you've already seen this. Normally that's what teachers say. No, you've already studied in this year. Okay, I think I've already made it. I don't remember. Yeah, you can memorize. I've already made it for you. I'll share that also. Okay, just memorize this one. I'll give you some time. Yeah, I can see everything. Yes, it's ready. Yeah, actually, memorize the last one. The last table, the last image has all the image, all the formulae. Memorize them. Children, the last image I've shared on WhatsApp is a consolidation of all the formulae which we'll be using in this chapter. Please memorize them. I'll give you some time, 10-15 minutes time. Please memorize. Yeah, online students and here children, you also. Sorry to disturb. So for a sphere, the TSA is 4 pi r square. For a sphere, the TSA is 4 pi r square. Now, for a hemisphere, now just imagine a big laddu, okay? A big laddu, a perfectly spherical laddu. A perfectly spherical rava laddu. Now you cut it into 2 equal halves. So now each half is a solid hemisphere. That big rava laddu, okay, spherical in shape, is an example of a solid sphere. Solid sphere. It was filled, packed with material. It's a solid sphere. Now, when you take a football, it's a hollow sphere because there's air inside. There is air inside. That's hollow. Solid is like this. I'm saying this laddu. So when you cut that into 2 equal halves, each half is a solid hemisphere. Now this hemisphere will have CSA and one circle on the top. Imagine, as I'm saying, you should imagine that laddu, 2 equal halves. So there is one CSA and there's one circle on the top. All right. So for this CSA, it will be 2 pi r square. For the circle, it is pi r square. So the total surface area of this solid hemisphere will be 3 pi r square. I'll come again. Sphere, 4 pi r square. Surface area. Hemisphere, the CSA will be 2 pi r square. This is 4 pi r square, so that will be 2 pi r square. But in addition to that, in a solid hemisphere, there's one circle on the top also. So plus pi r square. So 3 pi r square. So for a hemisphere, you can see the formula. Curved surface area is 2 pi r square. Curved surface is only the outer one, the CSA. Total surface area is plus a circle on the top. That also, supposing it is a bowl, a hemispherical bowl. Hemispherical bowl. The total steel used to make that bowl is only 2 pi r square because that bowl has steel only in the curved surface area. That circle on the top is open. There is no steel, there's no material used to cover the top because of the bowl. Then the area, so in the case of the bowl, which is in the case of this hemispherical bowl, the area of steel used to make the bowl is only the CSA. Because where is that material? Only in the CSA. That circle is open on the top. So the TSA for the bowl will be the total surface area of the steel used to make that bowl will be only 2 pi r square, not 3 pi r square. 3 pi r square is only when when the circular portion on the top is also covered. Otherwise, it's only 2 pi r square. Get that? Okay. So if it is hollow, if the hemisphere is hollow, with a hemispherical tank, if the hemispherical open tank, okay, then that will have only the CSA. On the top circle is open. So only 2 pi r square you can calculate. 3 pi r square you will calculate only when the top circle is closed with material. Otherwise, it's only 2 pi r square. Okay, that's about the difference. And in the hemisphere, the depth of the hemisphere is equal to the radius. See the figure. The depth of the hemisphere, if it is a hemispherical bowl, not any bowl. Some bowl in your house won't measure the radius and height and say, teacher told us something incorrect. The radius and height are not for any bowl. If the bowl is a hemispherical bowl, the perfect hemisphere. Okay. So for the perfect hemisphere, then the radius will be equal to the depth or the height of the hemisphere. So extend this to now this one, the wall is thin. If it's a bowl here, the wall is thin. The same bowl here, the wall is thick. So for this example, I can give you half a coconut. If a coconut is a perfect sphere, then it's called a spherical shell. I don't have that. This one. If a coconut is a perfect sphere, Ignore that fiber, extended fiber, ignore that. Okay, now that will, along with that, it will not make a spear. That fiber which you hold the coconut, ignore that. It's a perfect spear. The coconut is an example of if it is perfectly spherical, children. See, every coconut is not perfectly spherical, but there are, some coconuts are really perfectly spherical. So now that coconut is an example of a hollow spear, which is empty inside. Inside it's empty, no? It's like there is one hollow spherical cavity where there's that tender coconut water. That area is empty, right? There is no material there. Some chocolates also available like that. Inside it's hollow. You bite, you think there's something, there's nothing inside. Well, I'm not fond of chocolate, I'm just telling you. Correct? It's yeah, I don't know. You understand that? Otherwise, there's a nut or something inside it. Yeah, so there are some chocolates also like that. You can just think of a coconut. A coconut, a perfectly spherical coconut is an example of a spherical shell. Spherical shell meaning inside there's a spherical cavity. Inside there's a spherical cavity. Then the volume of the material will be external volume minus internal volume. 4/3 pi capital R cubed minus 4/3 pi small r cubed. Now here you cannot use area of uniform cross section because it does not have a uniform cross section. It has a cross section, but it's not uniform. You cannot stack up many identical things and get a sphere. You can stack things and get a sphere, but they will not be identical. They'll keep increasing in size and then again decreasing in size. So something like that. So a cone also. A cone has a cross section, but doesn't have a uniform cross section. Okay. So this one, in the case of a coconut, the volume of the material is 4/3 pi capital R cube minus small r cube. But if you want to find the volume of the space inside, that will be only 4/3 pi r cube because inside it's spherical. So the volume of the sphere will be 4/3 pi r cube. The formula to find the volume of a sphere is 4/3 pi r cube. The formula to find the volume of a sphere is 4/3 pi r cube. Now inside the coconut, if the cavity is spherical, inside the coconut, if that cavity is spherical, so supposing you have a box, like a coconut, you can just open and close it. That space inside the box I'm talking about. If you have a box, okay, like in a coconut, you can just open it and close it like that. The space inside I'm saying, the space inside is a sphere only. Inside it's a sphere with radius small r. That volume is only 4/3 pi r cubed. That's what you see here. In the case of a hollow sphere like this, the volume of the space inside the shell, inside the coconut, is only one sphere's volume, 4/3 pi r cubed. But if you're talking about the volume of the material, this material, the thick thing, the material, then it is 4/3 pi capital R cube minus small r cube. So 4/3 pi r square, 4 pi r square. So here it will be 4/3 pi r cube minus r cube. Here it is only one r cube, no? Here it will be that r cube, 4/3 pi r cube minus r cube. Similarly, 2/3 pi r cube, because half of this one is 4/3, no? So 4/3 pi r cube and half of this, half into, so 2 ones are 2 twos are. So 2/3 pi r cube. Half of 4/3 pi r cube. 2/3 pi r cube. That is for a hemisphere. CSA 2 pi r square, 3. So it's easy to remember. 2 pi r square, 3 pi r square, 4 pi r square. For a sphere, 4 pi r square. For a hemisphere, 2 pi r square, 3 pi r square. For hemisphere, you will get 2 pi r square and 3 pi r square. For a sphere, you will get 4 pi r square. Now, if this, so this is half of a coconut. This is half of a coconut. So this is the outer CSA. Inside this one is the inner CSA. And this is the ring on the top. This is the ring on the top. So all these three surfaces make the area of the hollow hemisphere. If the wall is thick, the area available to be painted, half a coconut will look like this. Okay, so the surfaces in that coconut will be, you'll find that white inner CSA, then the outside brown outer CSA. Then on the top here, you'll see that ring on the top. Can you visualize that? So the area will be the sum of these three areas. The area will be the sum of these three areas. So CSA we know for a hemisphere is 2 pi r square. See here. CSA is 2 pi r square for a hemisphere. 2 pi r square for a hemisphere. So keep the 2 pi r square in mind. Inside will be 2 pi small r square. Inside, this is 2 pi small r square. Outside, this is 2 pi capital R square. This ring is pi r square minus r square. Only one ring. For a cylindrical shell, there'll be two rings, one on the top and one on the bottom. So top pi r square minus r square, bottom also pi r square minus r square. Here is only one such ring. So pi r square minus r square is for the area of the ring. Inside it is 2 pi small r square, outside 2 pi capital R square. Find these three areas and add everything. That will be the area of the hollow hemisphere. If you have some object like this and you have to paint up all over, that will be the total area to be painted. Here also find 2 pi r square in pi only. Don't use the value of pi. So if that is 10 pi, then like 2 pi capital R square. It is 20 pi. And that pi r square minus r square, maybe like 5 pi. So totally you get 35 pi. Once for all, use the value of pi, 22 by 7. So it's easy to calculate. Mostly. Like this only it happens. So it's better you don't use the value of pi. So you can see here. So, okay, all this now you can understand. And now this volume of the material, volume of this material will be external volume minus internal volume. What's the volume formula? 2 by 3 pi r cube. Volume formula is this one. So 2 by 3 pi capital R cube minus 2 by 3 pi small r cube. So on taking 2 by 3 pi common, you'll get r cube minus r. So now have a look at the formula. Another 5 minutes. We'll take up some questions you can understand better. Online students use the emoji. Raise your hand. Prashant, Prajit, Raghavi, Rakshita, Danya, Florentina. Somebody is missing. Krishmi is not there. Sashank, Prajit, Raghavi, Rakshita, Danya, Florentina. All the children. Thank you, children. You're there, right, Florentina? Okay. Done. Yeah. Yeah. Answer the first one, children. Please write down the question. You can leave a page or two to write the formulae. The last image which I shared, no, it's enough if you write only that. Okay, so leave some page, or if you've already written, good. Now take down this question, draw the figure which you see, and find the values of those variables mentioned. I'll just make you understand so I've written cone, below that I've written R, H1 and L. You understand that? And I've written cylinder R and H2. Please understand cone. Okay, the solid in figure, the first question is a cylinder surmounted by a cone, correct? The solid in question number 1 is a cylinder surmounted by a cone, or a cone mounted on a cylinder. A cone mounted on a cylinder. Okay, so there are two solids there, one cylinder, one cone. Now for the cone, you have radius, height, slant height. For the cylinder, you have only radius and height. For cone, we have radius, perpendicular height, slant height. For cylinder, we have only radius and perpendicular height. So I want you to find the values for the cone. I want you to find what is R, what is H1, and what is L. And for the cylinder, I want you to find what is R and what is H2. I've used H1 for cone and H2 for cylinder. Yeah. Don't answer the question. Don't find, I just want these values. That's all. I don't want anything else. I just want the values. Please write the question. Please write the first question, draw the diagram, and tell me only the values. Yeah. Done, children? Ready with the values? DM, decimeter. Sorry? Oh, conversion. Okay. So I'll just write the metric chart for you. Yeah. So we have millimeter. I'm writing in the ascending order. Millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. Yeah. Values ready? Is Tanya there today? Yeah, Tanya's there. Okay. Yeah, anyone online, tell me the radius of the cone and the cylinder.
18 centimeter.
Centimeter?
18 meters.
18 meters. Is the radius of the cone and the cylinder the same? Yeah,
Yes,
because
ma'am.
it's surmounted. It's surmounted. If not, it will be mentioned. If nothing is mentioned, they are the same. If they are not the same, it will be mentioned. The radius will be given different for the cone and the cylinder. Okay. So the radius for the, because the diameter is 36 meters, so the radius will be 36 by 2, 18 meters for both cone and cylinder. That's why we have not written R1, R2. It's R only for both because the radius is the same. If they're different, then we'll say R1, R2. Okay, now the height of the cylinder. Okay, so a tent of height 77 decimeter. Now what? Yeah, I know, Navya, you're busy calculating the final answer, but please listen. Yeah. Now, when we say tent, now when we say tent, that includes the cylinder and the cone, right? Yeah. When we say tent, it is a cylinder and the cone together is a tent. Now, the height of the tent of height 77 decimeter. So that's the height of the cone and the height of the cylinder. The vertical height of the cone and the vertical height of the cylinder together is 77 decimeter. Okay. Is in the form of a right circular cylinder of diameter 36 meters. Cylinder of diameter 36 meters and height 44 decimeter. So height is height of the cylinder or height of the cone?
Cylinder, ma'am.
Cylinder. Because it's given right circular cylinder of diameter 36 meters and height. Cylinder of diameter and height. So it is the diameter of the cylinder and the height of the cylinder. Yes or no? Okay. The height of the cylinder is 44. But what's the height of the tent? 77. So 77 minus 44. 33 is the conical height. Correct? Because the height of the tent is 77. What is the height of the tent? It's the cone's height of the cone plus the height of the cylinder. So 77 minus the cylindrical height. 44 will give you the conical height. Correct? So you have a question there, Arjun? Okay. So H1 is, what is the height of the cone, H1?
33, ma'am.
33. Okay. And H2? 44.
44.
Very good, 44. Did you find the slant height of the cone? How do you find the slant height of the cone? Yeah, so here it will be root of h square, root of r square plus h1 square. Here it will be L is equal to square root of R square plus, because we have called the height as H1, no? So H1 square. So it is root of R is 18 square plus H1 is the height 33. Find this. Huh?
But 18 is in meters and 33
Oh, I
is in
didn't notice that.
decimeters.
Okay, yeah. Sorry. Yeah. We have to change. Thanks, Navya and Sashant. Yeah, I didn't notice that. Fine. This is the formula. I'll stop here. Now, are we all which unit are we all converting to?
Meter, ma'am.
Meter. Yeah, even I thought the same. Meter. Convert everything. Have everything in meters. Have everything in meters. Radius is already in meters, 18 meters. Height. Have both the heights in meter. Yeah. Find the slant height. Anybody found the slant height already?
Ma'am, I got it as 330.49.
Okay, 1 second. So it will be root of what is H? What's the height of the cone? 33. Okay, so 33 decimeter. 33 decimeter. 33 decimeter is not 330 meters. 3.3. Sashank, you converted to meters or decimeter?
Meters, ma'am. I did a mistake.
Oh. So radius is 33 decimeter. And height is, no, I'm confusing. 1 minute. 1 second. What's the radius, children? 18 meters. Yeah, you converted 18 meters to, okay, I don't know what you did. So you have 18 meters at the 18 meters itself. And what is the height? Height is equal to 77 minus 44. So 33 decimeter. So decimeter to meter, you need to divide by 10. 3.3.
I'm getting 18.3, ma'am. L value.
It will be 324 plus 3.3 into 3.3 plus. Yeah, you got 18.3 using a calculator.
Yes, ma'am.
Calculators are not allowed in the examination session, Rajit.
Yes,
Please
ma'am.
see, because if we can't calculate, then we'll be stranded there itself. No, you cannot proceed. You might know the entire procedure, but if you can't find L, then you're stranded. You cannot proceed. So please find L, all of you. Okay, so for those of you who want to understand how to convert, if it's confusing, if you should multiply or divide, I'll just tell you, please listen. When you're converting downwards, we need to divide. When you're converting upwards, multiply. So we have chosen to have everything in meter. Okay, so the radius is already in meters, 18 meters. This is good. Put a tick. Now H1 is how much? 33. But decimeter, you wish to have it in meters. So now what to do? So decimeter, you want to convert to meter. See, this is decimeter. You want to convert that to meter. So you have to, you're coming down the chart. So you should divide. See the arrow. If you're coming down, you should divide. So you should divide. Divide by what? See, a decimeter to meter, no, 1, 0. You should divide by 10. Just that will give you the number 1, 0, 10. So divide by 10. So 30 to convert decimeter to meter, you have to come down. So divide by 10. So 33 by 10. 33 by 10 by 10, which is 3.3 meters. That's one thing. Now L is equal to root of H square. So here H1 square plus R square. So it is root of 3.3 squared plus 18 squared. So the answer will be in meter. What you get will be in meter. Find this value. I want you all to calculate this. I'll see the square root now. How you can calculate it. How much? Oh, that only you should find. Root of that one you should find. You got it? Using the long division? Just take a picture and share the image, Madhumika. Hmm? But did you do the long division? That special long division, 8th standard division? You've done that and got 18.3. Okay. This chart, if you've forgotten, please make a note of this chart. I'm going to erase it now. Please make a note of the chart. So what is 33 into 33 or 3.3 into 3.3? How much is that?
10.89.
10.89 plus 324. So that will be square root of 334.89. 24 plus 10 is 34, 34.89. You need to add carefully. Yeah. No, I can write it for you if you see again. 324 children is 324.00. And then 10.89. Like this, you'll have to add. 324 is 324.00. And 10.89. So it will be 334. Okay, Madhumita. All right, like this. 3. Now, how do we do the long division? 334, right? Okay, so this is how we add. So now we're going to find the square root of 334.89. So you need to group. Now before the decimal point, you need to group in pairs in this direction. So 3 stands alone. After the decimal point in this direction, we need to group in pairs. Before the decimal point, I'll see your division just a second. See, like I'll give you some number. Like supposing you have 456,073.5692. Before the decimal point, we group 736045 like this. After the decimal point, 5692 in this direction. After the decimal point in this direction, before the decimal point in this direction. So 3, 4 makes a pair. 3 stands alone. After the decimal point, we need to pair in this direction. 8, 9 makes a pair. Now 1 is 1 is 1. 2 is a remainder. The next pair comes down. You need to double the quotient, so it becomes 2. Whatever digit you place here, you should place the same digit here. All right. So because you said 18.3, so it should be 8. 8 8 is 64, 4 6 carried over. 8 2 is 16 plus 6, 22. 10. The next pair comes down, 8, 9. Keep a decimal point, double the quotient, 36, 3, 3, 1, 0, 8, 9. I did not explain. I won't say that I explained. I'll share the video where you have this explanation. So if you want to recall, you can watch that video. I did not explain now. I was just so some faint idea if you can get. This is how we find the square root of a number. So doing this method, we get 18.3. Slant height is exactly 18.3 meters. Now the question. So now we've got all the values. We've got all the values, right? What about for the cylinder? Cone radius 18 meters, cylinder radius 18 meters. Height cylinder
44.
or meters. In meters, 4.4 meters. And this is H2. H1, 3.3 meters. And slant height, 18.3 meters. Now let's answer the question. We need to find the cost of the canvas. So a tent is put up. A tent in this shape is put up using this material canvas. Canvas is used to put up a tent like this, a cylindrical, a cylinder surmounted by a cone. Now tell me, where all will this material canvas be used? Will it be used on the floor? Will the material canvas be used on the floor? No, it will not be used on the floor. On the floor, maybe you'll put a chair and sit, or maybe you'll spread a mat and sit down, or you'll just sit on the bare floor ground or a stool. You will not cut canvas in circular shape and put it on the floor. We don't do that for a tent. Okay, so tent, the canvas material is not cut in a circular shape and put on the ground. No, it's not. So canvas is not used on the floor. Is the canvas used to make the CSA of the cylinder? CSA of the cylinder? Yes. Then the cylinder has a top, no? Is this canvas used to cover the top of the cylinder? No. Is the canvas used to make the CSA of the cone? Yes. These are, see, if you have a cylindrical base like this, and if you cover the top of the cylinder, what's the point having the cone on the top? You've covered it. Then what's the point having the cone on the top? That cone is to increase the air space inside the tent, probably. So if you make a cylindrical tent and you cover the top circle with canvas and then you put a cone on top of that, what is the purpose of the cone? It's not going to serve the purpose of an attic. Like we have an attic, no? In the house, we have attics, no, where we store clothes on the top. What we say, loft or something. So you put your things you don't use regularly, we put it there. So tentla neenga attic la era mudiyadhu. Tentla and attic la vachi eri poi onnu vekka mudiyadhu. So if you're covering this one, why then the conical part? Yes or no? So where all is the canvas used is what you'll have to think. The canvas is not used on the floor. The canvas is used to make the CSA of the cylinder. Then the cylinder bottom, no canvas. Cylinder top also no canvas. Then the cone, CSA alone canvas. So the area of canvas used to make this tent is equal to CSA of the cylinder plus the CSA of the cone. What's the formula to find the CSA of the cylinder? 2 pi RH. You can see your book and at least say correctly. Yeah, no, really. At least that way we'll say 2 pi RH. And the CSA of a cone, pi RL. So find 2 pi RH, find pi RL, add both to get the area of canvas needed to make this tent. And then multiply that with the rate given. What is the rate? The rate is 3 rupees 50 paise per meter square. Since we have all the values in meter, all our radius, height, everything is in meter, we'll get the area in meter square. Multiply that area with 3.5 to get the cost of the canvas. 1 meter square of canvas is 3 rupees 50 paise. You would have found that area in meter square, no? So 1 meter square, 3 rupees 50 paise. Supposing you got 100 meter square, 100 meter square, how much? Multiply by 3.5 to get the cost of the canvas. So to find the cost of the canvas, you should not find the volume. You must not find the volume of the cylinder and the volume of the cone. Canvas is used to make the surfaces. Should find the area, the surface area. You're not filling something inside the cylinder. I'm sorry, inside the tent. Should not find volume, you should find the area. Okay. Second one. See, online students, and here also, if you have any questions related to the first one, please ask me. Any value you don't understand, how to find the square root by long division method, that I'll share a video. Apart from that, if you have any other questions, please ask me. Online children? Finished, Anirudh? What happened? Oh yeah, you can come. Come. Okay, no questions. Fine. Second, no, not the second one, children. Third one, no, only the figures. The third one, children. Calculate the surface area. Get the values for the third one.
Third one. First and second one already done. The other plus.
Find the mode. Huh?
No, it's the first one.
This one.
Find the average, how to find the average.
Add all the values and divide by 1, 2, 3, 4, 5, 6.
That is mean.
Yeah, that's only the average. That's the average. Finish writing the question. Okay, so for the third figure, What is for the cone, what's the radius? If I zoom in, no, I can't write, so I have zoomed out. Yeah, what's the radius of the cone?
5, ma'am.
All in centimeter only, no? We have,
Yes.
okay. Radius of the cone, 5. What's the radius of the cylinder? 5. What's the radius of the hemisphere? Okay. Then for the cone, what's the height of the cone?
12, ma'am.
12 centimeter. Height of the cylinder?
18.
80.
13, ma'am.
Very good. 13. Okay. What is 18? It is the height of what plus what?
Cylinder and hemisphere, ma'am.
Cylinder
and hemisphere.
Yeah.
Very good. Yes. 18 centimeters is the height of the cylinder plus the height of the hemisphere. Hemisphere also has height. 18 centimeters. 18 centimeters is the height of the cylinder and the height of the hemisphere. And hemisphere's height we know is equal to its radius. So what is the radius? 5. So 18 minus 5. 13 is the cylindrical height. 5 is the hemispherical height. Totally 13 plus 5, 18. Yeah, so there we have to be careful. So if we take this value incorrectly, the answer is wrong. Okay, so for the cylinder, the height is 18 minus 5, 13 centimeters. Okay. And then for hemisphere formula, we have only R value. So for hemisphere, R is enough. Because in all the formula for hemisphere, we only substitute R. For cylinder, radius and height we have. For cone, if it is area, you need to find slant height. That is root of h square plus r square, 5 square plus 12 square. So this is easy. 25 plus 144, 169, which is 13. Okay, very good. Now, how do we find the surface area? Calculate the surface area. Now, this is not a tent or anything. It's some object in the shape. It can be hollow. Inside it can be hollow, or maybe it is filled with, meaning it's solid, whatever. The question is only surface area. So it's got to do with the outside of the solid, nothing to do with the inside. So whether it is empty, meaning it's hollow inside, it's solid inside, need not be our concern. Yeah. So here what we should understand is be careful while taking the height of the cylinder. Height of the cylinder is 18 minus 5, 13 and not 18. Okay, now tell me children, how do we find the surface area? Just tell me in words, no, like CSA of this, TSA of that, all that put together, like that. CSA of the cone? Yeah, okay, online students? Just tell me in words, like CSA of this one plus TSA of that one. Use CSA and TSA and just tell me the, the expression used to find the area.
CSA of cone plus TSA of cylinder and CSA of hemisphere.
Perfect. So it's like you have to paint the outside. So outside what all is visible? Only CSA is visible. Outside you can see only the curved surface area of the hemisphere, the curved surface area of the cylinder, and the curved surface area of the cone. Only these can be painted. That's all is visible outside. So only this you should find. So it will be for the cone, it will be pi RL. For the cylinder, 2 pi RH. And for the hemisphere, 2 pi R square. 2 pi R square. Yeah, that's about this one. Yeah. Fourth one, children. 4. So this will be your homework. Answers to this one we'll discuss on Thursday. Meaning I'll work and share it on WhatsApp. Nothing to discuss. I'll share the answers on WhatsApp. So please work the answers to these questions. Now we are discussing only the values. Yeah, please answer the fourth one. find for the cone and cylinder, radius, height, slant height, and all that. Done, children? Yeah. Yes. Do you want to answer? Yes, Ritik. Okay. What is 20 centimeters? It is the height of. It's the height of the cone plus the height of the cylinder plus the height of the cone. And the two cones will be identical. They'll not have different heights. Yes or no? They have to be identical. So height of the cone plus the height of the cylinder plus the height of the cone is 20. What is the height of the cylinder alone? Okay, next, what should you do? Now with 20 and 16, what will you do? Yeah. Correct, that's it. What is the? I've given there no diameter. I've written that diameter is 7 centimeters. You can see that in the figure. No, your question height is what you said now. Okay, now your question is what is the radius for this? The radius for the cone and the radius of the cylinder will be the same, right? Because they're stuck to each other. It will be for both the cone and the cylinder, it will be 3.5. Yeah. Yeah, so what's the radius of the cone? 3.5. Radius of the cylinder? 3.5. Because you're chatting with somebody or you're calculating? You were chatting with somebody? Calculating. But what are you calculating now? 7/2, huh? Okay. So cone and cylinder radius 3.5. Height of the cylinder 16. Height of the cone?
4.
Height of the cone?
4, ma'am. 20.
2 centimeter.
2 centimeters. Okay. So this full thing, height of the cone plus the height of the cylinder plus the height of the cone is 20. So 20 minus the cylindrical height, minus the cylindrical height is 4, which is the height of the two cones. So the height of each cone will be 4/2, which is 2. This total length is 20. That is the height of the cone plus the height of the cylinder plus the height of the cone is 20. So from 20, if you remove the cylindrical height, the height of the cylinder, you get 4. And what is this 4? It's the height of the two cones, height of the cone in the left end and the height of the cone in the right end. Together is 4. So 4/2, 2 centimeters will be the height of each cone. 2 centimeters, 2 centimeters. Cylinder's height 16, cone's height, each cone's height 2 centimeters. So for the cone, radius 3.5, height 2. And for the cylinder, radius 3.5, height 16. You can find the slant height using the formula.
4.5.
And then, yes, Prajit?
4.5, ma'am. L.
Oh, you calculated L, is it? What's it?
4.5, ma'am.
Oh, no, but you would have got you have taken HS4, no? So I think you'll be wrong.
I think I took it again, ma'am.
Oh, that's pretty fast. Okay, so 3.5 squared will be 12.25 and then plus 4. 16.25. 16.25 perfect square? No, right? That's what. 4.03. Yeah, 4.03. Calculate for phone or you calculated? Did you calculate? Both of you calculated? Okay. 4.03. 4.03, correct. Understood, all of you? So how do we find the TSA of the solid? How do you find the TSA? Correct. CSA of the cylinder plus the CSA of the two cones. Only the curved surfaces are exposed. You can see only the curved surfaces. So it's a CSA of the cylinder plus the CSA of one cone plus the CSA of the other cone. So pi RL plus pi RL plus 2 pi RH. So you can find pi RL once and multiply by 2. And then 2 pi RH, add to get the TSA. Okay, I'm sharing these two images now on WhatsApp, children. Please, no, I don't. No, I think we'll continue this in tomorrow's class because certain things I have to tell you. I don't want you to do this by yourself. So we'll continue this in tomorrow's class, children. All right. All right, online students and children here. That's it for today's session. Thank you so much. You can leave the call. Any questions, you can stay back and ask me.
Thank you.
Thank you, Dani.
Thank you, ma'am.
Thank you, Project.